So last question of the exercise. What we have is this USAMO question from 2009. Given circles W1 and W2 intersecting at points X and Y, so let's just get to it. So X here, Y here. Oh shit. I'll charge that later. Okay. Let L1 be aligned through the center of W. So let's call this omega 1, omega 2. Hence this is O1. This would be O2. Line 1 be aligned through the center of through O1, intersecting omega 2 at points P and Q. So let it just cut like this, I suppose. So P and Q. Another line, do the same thing, just R and S, okay. So here's R, here's S. Let me just mark out the points. So they're saying that prove that if they are concyclic, then the center of circle lies on the line XY. So if this, I didn't draw this nicely, to be honest. I think I messed it up, because no way this is cyclic. Let me just try. Yeah, maybe I should redraw this. Okay, yeah. Drawing is important. So, okay, let me just bring this back there. And, okay, let me just do this. P, Q. So you need, I'm gonna work backwards. This, something like that. Okay, something like this. So R here, S here. Okay, this is almost perfect. R and S. Okay, if P, Q, R, S are on the side, on the circle, then the center of the circle, let's call this big O, lies on the line XY. So let's just plot the line XY and O. So my drawing is not that accurate. Don't care, we can just shift O over. So prove that O lies on the line XY. So what we have to know, first of all, is that XY is radical axis between omega 1 and omega 2. Right. So all we have to do is to prove that big O also lies on this radical axis. what this means more concretely is that proof that power of big O with respect to W1 equals that of W2. That means that is basically a more concrete way of saying that O lies on the radical axis of W1 and W2. So how can we do that? Well, first of all, let's write down what this statement means. Okay, power of O with respect to W omega 1 is what? It is O1 squared minus R1 squared, where R1 is the radius of omega 1. Then that of omega 2 is O2 squared minus R2 squared, where R2 is the radius of omega 2. And more concretely, O1 squared, R1 squared in this case is O1s, and R2 squared is O2q, because this would be R2 and this would be R1. Okay, now rearranging a little bit, we get O1 squared plus O2q squared equals O2 squared plus O1s squared. So we have to prove this. Okay, so notice that when we draw a line O to O2, it intersects PQ, which is the radical axis between the red circle and omega 2. Let's call this at X, and it's at 90 degrees. Okay, so we'll write that O1 squared minus OQ squared is equals to O1 squared is just this one. And we apply Pythagorean to this triangle. Okay, which is, let me just erase that. OX squared plus O1x squared. Then OQ squared is OQ squared. We apply Pythagorean to this triangle. Okay, so it's OX squared minus OX squared plus XQ squared. So notice that the OX's cancel off. You get O1x squared minus XQ squared. So O1x squared is this one. And we can apply Pythagorean to this triangle. So O1x squared is actually O1 O2 squared minus O2x squared, and the minus xq squared is, let me just erase this. Oh shit. Okay. Yeah, we are at xq squared, which is this. Hey, wait, no. Xq squared is this. We can notice that here we have O2x squared, which is this length. So what we want to do is we want to get this length to be cancelled out. Okay, so we can write it from the perspective of this triangle here, O2x and q. So xq squared is O2q, let's just use big Q from now on, minus O2x squared, O2x squared. So the x squared cancels out, and you get O1 O2 squared minus O2q squared. So compared to the thing that we want to prove, right, you can see that it's kind of close. This is the thing that you want to prove. So you have O01 and O2q squared. So it's very close. Let's just rearrange this further a little bit. O01 squared plus O2q squared is O1 O2 squared plus OQ squared. So it's just the right side that's a bit wonky, that's not really like it. Well, just now remember that we only considered this half, considering the 90 degrees between these two, but we haven't even considered this part where you can connect this. Let's call this y. It's a 90 degrees or so, and you get the same kite structure that you can manipulate here, right? So we can, okay, and also notice what we want, what we need. So to get from here to what we have now, which is this one, to what we want to prove, notice that we're missing O2. So we can replicate what we just did in this step with just O2 squared and something. Okay, so let's work on that. O2 squared gives you a hint of what triangle we need to look at. Obviously it's this one. Okay, so, and just now we did minus OQ squared, now we just do minus OS squared to get S introduced in here. Okay, so O2 squared minus OS squared equals, Pythagorean is O2y squared plus OY squared. So O2, wait, O2y squared plus OY squared. Then you minus OS squared is OY squared. OY squared plus SY squared. Hold up, is this correct? Okay, SY squared. Notice that what we don't want the length OY because it's basically useless, but they cancel out nicely here, so it's O2y squared minus SY squared, minus SY squared. Okay, so SY squared we also don't want. We want to convert it into something that we want. So you look at this, we see SY squared. We want what? We know that we want O1S squared. So obviously we will take a look at this triangle. So SY squared is O1 is equivalent to, let me just copy the thing on the left first. This one stays. SY squared is O1S squared minus O1Y squared. O1Y. Yeah. I think that's right. Okay. Now let's see. And now we should expand O2y squared. So O2y squared is O2y squared is here. Okay, wait, it's getting a bit messy. Now we can consider this. Yeah, okay, got it. This triangle to get rid of O2y squared. So O2y squared is O1 O2 squared. So this is O1 O2 squared minus OY squared, O1y squared. Then you minus off O1s squared plus O1y squared. This one cancels. You get O1 O2 squared minus O1s squared. Now you rearrange, you get O2 squared minus plus O1s squared equals O1 O2 squared plus OS squared. And look what we have here. So just now we realized that we secured this side, but this side is wrong. this side is wrong. Okay. But right now, if you realize, we have the right side correct. 002 squared or 1s squared. But the left side is 0102 squared plus OS squared. Which is wrong. So the idea is actually to combine these two together. We want one side from each, right? And we notice that one side is wrong from each. But what have I told you? That since S and Q both lie on the circle, OQ will be the radius of the red one. OS would also be the radius of the red one. So looking at these two, that means OQ equals OS. So OQ squared, OQ squared equals OS squared. So O1O2 squared plus OS squared will be equals to O1O2 plus OQ squared. So we can, since the red highlighted parts are equal, we can equate the yellow highlighted parts. So we have O1 squared plus O2Q squared equals O02 squared plus O1S squared, which is what we wanted here. Yeah, so we proved it. So hence O lies on radical axis xy extended true, and we're done. So that's all.